Picture this. It's the year 1600, and you're standing in the middle of what looks like a completely impossible construction project. You're staring up at a mountainside that's been carved into thousands of perfectly level pools, each one reflecting the sky like a giant staircase made of mirrors. Water flows from pool to pool in a system so complex it would make modern engineers scratch their heads in amazement. Welcome to the rice terraces of the Ifugao people in the Philippines, where farmers turned vertical cliffs into horizontal farmland, using nothing but hand tools, incredible ingenuity, and more backbreaking work than you can imagine. Here's something that'll blow your mind. These terraces weren't built by some ancient civilization with mysterious lost technology. They were constructed by regular farmers who figured out how to make water flow uphill, how to prevent mountains from washing away, and how to feed entire communities on slopes so steep that mountain goats would think twice about climbing them. We're talking about agricultural engineering that's so sophisticated, it puts most modern farming techniques to shame. But before we dive into this incredible story, make sure to hit that subscribe button and give this video a like. I promise you're about to learn something that will completely change how you think about what's possible with human determination and clever engineering. And when we're done, drop a comment telling me what surprised you most about these mountain farmers. Trust me, there's going to be plenty to choose from. Now, let me tell you something that might sound completely crazy. The Ifugao people basically convinced an entire mountain to become a farm, and they did it without bulldozers, without concrete, and definitely without any engineering degrees. What they had was something far more valuable: generations of knowledge about how water behaves, how soil works, and how to make stone walls that could last for centuries. The whole project started with a problem that would have sent most people packing. Picture a valley so steep that dropping a stone from the top would send it bouncing down the mountainside like a pinball. The soil was constantly washing away every time it rained, which in the Philippines happens a lot. Meanwhile, the flat land at the bottom of the valley was tiny compared to the number of people who needed to eat. Most farmers would have taken one look at those impossible slopes and decided rice farming wasn't for them. But the Ifugao people saw something different. They looked at that rushing water and thought, what if we could slow it down? They looked at that steep slope and wondered, what if we could make it flat? They looked at all that wasted mountainside and asked, what if we could turn it into thousands of perfectly level rice fields? It was the kind of thinking that either makes you a genius or gets you laughed out of town. The first challenge was figuring out how to make level surfaces on a slope that was basically vertical. This wasn't like building a bookshelf, where you could just grab a level from the hardware store. These farmers had to become master surveyors, using nothing but rope, wooden poles, and their own eyes. They developed a system so accurate that modern engineers still use similar principles today. Here's how they did it. Teams of workers would stretch long cords across the mountainside, using wooden sighting poles to make sure everything was perfectly horizontal. It sounds simple until you realize they were doing this on slopes, where one wrong step could send you tumbling hundreds of feet down the mountain. Every contour line had to be perfect, because one mistake would mean water flowing in the wrong direction, which would turn their carefully planned rice fields into muddy waterfalls. The surveying process alone could take months for a single valley. Workers would start at the top and work their way down, marking each level with stakes driven deep into the mountainside. They had to account for drainage, water flow, soil depth, and about a dozen other factors that would make modern civil engineers reach for their calculators. And remember, they were doing all this math in their heads while balanced on slopes that would challenge professional rock climbers. Once they had their contour lines marked, the real work began. Building the terrace walls wasn't just about stacking stones. It was about creating a system that could hold back tons of water and soil while surviving earthquakes, typhoons, and centuries of use. Each wall had to be engineered to perfection, because failure wasn't just inconvenient. It could destroy years of work in a matter of minutes. The stone selection process was like choosing ingredients for the world's most important recipe, not just any rock would do. The Ifugao people became experts at identifying stones that would fit together perfectly, drain properly, and stay put under pressure. They learned which types of stone could handle water without crumbling and which ones would provide the best foundation for the massive weight they'd be supporting. But here's where it gets really interesting. These walls weren't just built on top of the soil. The builders dug deep into the mountainside, sometimes going down several feet until they hit solid bedrock. They were essentially keying their walls into the mountain itself, creating a connection so strong that the terraces became part of the natural landscape. It's like they were performing surgery on the mountain, inserting artificial bones that would support an entirely new skin of rice fields. The construction technique they used was pure engineering genius. Each stone was carefully shaped and fitted by hand, creating walls that were strong enough to hold back thousands of gallons of water, but flexible enough to bend without breaking during earthquakes. The walls had to be thick enough to support the weight, but thin enough not to waste valuable growing space. Every measurement had to be perfect. Behind these stone walls came layers of different materials, each serving a specific purpose. First, they'd pack clay against the back of the wall to create a watertight seal. This clay wasn't just any mud. It was specially selected and prepared clay that would expand when wet to create an even better seal. Then came layers of different sized stones and soil, each one carefully chosen to help with drainage while preventing the terrace from washing away. The backfill process was like creating a layer cake made of dirt and rocks. The bottom layer was large stones that would provide drainage and prevent water from building up behind the walls. The middle layer was smaller stones mixed with clay to create stability. The top layer was the precious soil where the rice would actually grow. Getting these layers right was crucial because one wrong move could create a weak spot that would eventually cause the entire terrace to collapse. What makes this even more impressive is the scale we're talking about. A single valley might contain hundreds of individual terraces, each one requiring its own perfectly built wall. Some of these terrace systems stretched for miles up the mountainside, creating landscapes that looked more like natural amphitheaters than farms. The amount of stone that had to be quarried, shaped, and moved by hand is almost impossible to calculate. The most challenging part wasn't even the construction. It was the water management system that had to be built alongside the terraces. Remember, the whole point of this massive construction project was to grow rice, which needs to be flooded at specific times during its growing cycle. That meant creating a system that could deliver exactly the right amount of water to each terrace at exactly the right time. The main water source was usually a spring high up in the forest above the terraces. But getting that water down to the fields in a controlled way was like designing a hydraulic system using nothing but hand tools and centuries of trial and error. The main canal had to follow the contours of the mountain while maintaining just the right slope. Steep enough to keep the water moving, but gentle enough to prevent erosion. Here's something that would impress modern hydraulic engineers. The Ifugao people calculated the perfect grade for their canals using nothing but observation and experience. Too steep, and the flowing water would carve the canal deeper and deeper until it became a useless gully. Too flat, and the water would slow down, allowing silt to build up until the canal was blocked. They had to get it just right, and somehow they did. The canal system itself was a masterpiece of engineering. The main canal would branch into smaller channels, which would branch into even smaller ones, creating a network that could deliver water to hundreds of individual terraces. Each branch point required careful calculation to ensure the water would split properly and each terrace would get its fair share. But the real genius was in the overflow system they built into each terrace. Every rice field was designed with a small spillway that would allow excess water to flow to the next terrace down the mountain. This created a chain reaction where water would flow from the highest terrace all the way down to the lowest, watering every rice field along the way. It was like a giant irrigation system powered entirely by gravity. The spillways had to be built to exact specifications. Too large, and water would rush through too quickly, potentially washing away the rice seedlings. Too small, and water would back up, flooding the terraces above. Each spillway was essentially a tiny dam with its own flood control system, and there were thousands of them scattered across the mountainside. The engineering behind these spillways was absolutely mind-blowing when you really think about it. Each one had to be positioned at exactly the right height to create what the Ifugao called the golden flow. That perfect water level where rice plants could thrive without drowning. Too high, and the terrace above would overflow and wash out. Too low, and the rice plants would sit in stagnant water that would eventually kill them. These farmers basically became hydraulic engineers through pure necessity and generations of watching water behave. But here's where things get really wild. They didn't just build these spillways and hope for the best. They created adjustable systems using wooden boards and stone weirs that could be modified depending on the season and the needs of the rice. During planting season, they'd raise the water level. During growing season, they'd lower it. During harvest, they'd drain the fields completely. It was like having a custom irrigation system for every single terrace, controlled entirely by hand. The maintenance of this water system was a full-time job that never ended. Storms would wash debris into the canals. Earthquakes would shift the stone weirs. Even normal use would gradually wear down the carefully carved spillways. The Ifugao people developed an entire calendar based around water system maintenance, with specific times of year dedicated to cleaning canals, rebuilding weirs, and adjusting water flow rates. What's even more impressive is how they dealt with emergency situations. When typhoons hit, and in the Philippines they hit hard and often, the entire water management system had to be ready to handle massive amounts of water without destroying years of careful construction. They built what we'd now call surge controls, temporary barriers and overflow channels that could redirect floodwaters away from the terraces during the worst storms. The timber sluice gates they used were engineering marvels in their own right. These weren't just wooden boards stuck in the water. They were precisely carved gates that could be raised or lowered to control water flow with incredible accuracy. Some of these gates were so well designed that a single person could control the water flow to dozens of terraces just by adjusting one handle. It was like having a master control panel for an entire mountain's worth of rice fields. Now, once they had the water flowing properly, they faced an entirely different challenge: preparing the actual growing surface. You couldn't just dump soil into these terraces and expect rice to grow. The growing medium had to be perfect, which meant creating what's called a puddle seal, basically turning the bottom of each terrace into a waterproof clay layer that would hold water without letting it drain away too quickly. The puddling process was back-breaking work that would make modern farmers grateful for their tractors. Workers would flood each terrace with just the right amount of water, then literally stomp around in the mud for hours, breaking down the soil structure until it became a smooth, waterproof clay surface. They'd use their feet, wooden paddles, and sometimes even water buffalo to churn the soil until it reached the perfect consistency. Getting the surface level was another challenge entirely. After all that stomping and churning, the bottom of each terrace had to be perfectly flat so water would distribute evenly across the entire growing area. The Ifugao people developed a technique using wooden boards that they'd drag across the muddy surface, smoothing out any high or low spots. It was like using a giant squeegee to create a perfectly level mud floor, but they couldn't just leave it flat. Each terrace needed what they called a lip, a slightly raised edge that would keep the water from flowing out too quickly while still allowing controlled overflow to the next terrace down. Creating this lip required incredible precision because it had to be high enough to hold the right amount of water but low enough to prevent flooding. Get it wrong and you'd either have dry rice plants or drowned ones. The timing of all this preparation was crucial. Everything had to be coordinated with the monsoon rains, which provided most of the water for the system. Start too early, and the prepared terraces would dry out before the rice could be planted. Start too late, and you'd miss the optimal growing season. The Ifugao people developed an intricate understanding of weather patterns that would put modern meteorologists to shame. While some workers were preparing the terraces, others were busy in the nursery beds, special small plots where rice seeds were started before being transplanted to the main terraces. These nursery beds were like intensive care units for baby rice plants. They had to be protected from harsh weather, kept at exactly the right temperature, and watered with perfect consistency. The seedling process was an art form in itself. Workers would select the best rice seeds, often saving them from the previous year's crop, and plant them in carefully prepared mud beds. The seeds had to be spaced perfectly, too close together, and they'd compete for nutrients. Too far apart, and you'd waste valuable growing space. The nursery beds were typically located close to the village, where they could be watched constantly for signs of disease or pest problems. Transplanting Day was like a massive community event. Entire families would work together to move thousands of tiny rice seedlings from the nursery beds to the prepared terraces. Each seedling had to be planted at exactly the right depth in perfectly straight rows. It was precision agriculture at its finest, with workers moving across the terraces in coordinated lines, planting hundreds of seedlings per hour. The transplanting process required incredible skill and speed. Workers would grab small bundles of seedlings from baskets, separate them into individual plants, and push them into the mud at precise intervals. Their hands moved so fast, it looked almost like a dance, with experienced planters able to transplant an entire terrace in a matter of hours. The timing was critical because rice seedlings are fragile and can't survive long out of water. Once the rice was planted, the real work began. These weren't like modern farms where you plant the crop and come back months later to harvest. Rice terraces required constant attention and daily maintenance. Workers had to monitor water levels, adjust flow rates, and watch for signs of problems that could destroy an entire season's work. Weeding was a never-ending battle. In the warm, wet conditions perfect for growing rice, weeds grew just as enthusiastically. Workers would wade through the flooded terraces almost daily, pulling weeds by hand and making sure they didn't compete with the rice plants for nutrients and space. It was like tending a garden the size of a small city, except this garden was scattered across an entire mountainside. The pest control methods they developed were ingenious in their simplicity. Snails were a constant problem, eating young rice plants faster than they could grow. The Ifugao people turned snail hunting into a community activity, with families competing to see who could collect the most snails from their terraces. The collected snails weren't wasted, they became protein-rich additions to family meals. Water management during the growing season required constant adjustment. Young rice plants needed shallow water, just enough to keep their roots moist, but not so deep that it stunted their growth. As the plants matured, the water level had to be gradually increased to support the developing grain heads. Near harvest time, the fields were drained completely to allow the rice to ripen properly. The paths and stone steps connecting the terraces became highways for daily farm work. These weren't just random trails. They were carefully engineered walkways that allowed workers to move efficiently between terraces while carrying tools, water, and harvested rice. Some of these stone steps were carved directly into the mountainside and were strong enough to last for centuries. The daily rounds on these terraces were like running a vertical city. Workers would start before dawn, climbing stone steps that zigzagged up the mountainside like a giant's ladder. Each family was responsible for multiple terraces scattered across different elevations, which meant a typical day involved hiking distances that would challenge modern fitness enthusiasts. But these weren't leisurely nature walks. Workers carried baskets of tools, buckets of water, and armloads of rice bundles while navigating paths barely wide enough for one person. What made these daily climbs even more challenging was the weather factor. During the rainy season, those stone steps became slippery as ice, turning every trip up the mountain into a death-defying balancing act. Workers developed special techniques for gripping the wet stones with their feet, almost like human mountain goats. One wrong step could send you tumbling down the mountainside along with a day's worth of carefully harvested rice. The timing of water adjustments was crucial and required split-second decision-making. Rice plants are incredibly picky about their water levels at different growth stages. Too much water during the tillering phase, and the plants would grow tall and weak. Too little water during grain formation, and you'd end up with empty husks instead of plump rice kernels. The Ifugao farmers became so skilled at reading their plants that they could tell exactly what each terrace needed just by looking at the colour and posture of the rice stalks. But here's something that would blow your mind about their water management skills. They could predict exactly how long it would take for a water level adjustment at the top terrace to affect the terraces at the bottom of the mountain. It was like having a mental computer that calculated water flow rates across hundreds of connected pools. Experienced farmers knew that opening a gate at terrace number 50 would raise the water level at terrace number 75 in exactly 43 minutes. Storm management was where these farmers really showed their engineering genius. When typhoons hit the Philippines, and they hit with the force of nature's own wrecking ball, the terrace system had to handle water volumes that would make modern flood control engineers nervous. The Ifugao people developed early warning systems based on cloud formations, wind patterns, and even the behavior of local birds and insects. The brush checks they installed were basically emergency brakes for runaway water. These temporary barriers could be quickly installed in canals when storms approached, slowing down water flow and preventing erosion that could destroy months of careful maintenance. Some of these brush barriers were so effective that they could reduce water velocity by more than half, turning potentially destructive floods into manageable irrigation flows. During major storms, entire communities would mobilize in coordinated response teams. Some workers would focus on adjusting water gates to prevent overflow. Others would reinforce vulnerable terrace walls with temporary supports. The most experienced farmers would patrol the main canals, watching for signs of erosion or blockage that could trigger cascading failures throughout the entire system. The social organization required for this storm response was as impressive as the engineering. Every family knew exactly which terraces they were responsible for protecting, and backup teams were assigned in case the primary workers couldn't reach their assigned areas. It was like having a volunteer fire department, except instead of fighting fires, they were fighting the forces of erosion and flood damage. Recovery after major storms was a community-wide rebuilding effort that could take weeks. Workers would assess damage starting from the top of the system and working their way down, because fixing problems upstream prevented additional damage to terraces below. The repair work required the same precision as the original construction, with damaged stones carefully removed, sorted, and reset using traditional techniques passed down through generations. Harvest time transformed the entire mountainside into a bustling factory operation. The timing had to be perfect because rice that was harvested too early would be soft and wouldn't store properly, while rice left too long in the field would shatter and fall to the ground. Experienced farmers could tell when rice was ready by the colour of the grain heads, and even by the sound the plants made when wind blew through them. The harvesting process itself was a masterpiece of efficiency. Workers would move through each terrace in coordinated lines, cutting rice stalks with small hand sickles and bundling them for transport. The bundles had to be tied just tight enough to hold together during the difficult journey down the mountain, but loose enough to allow proper drying once they reached the drying areas. Getting the harvested rice down from terraces high on the mountainside was a logistical challenge that would make modern supply chain managers sweat. Workers developed carrying techniques that allowed them to transport massive loads of rice bundles while still maintaining their balance on narrow stone steps. Some of the most skilled carriers could haul loads weighing more than their own body weight down paths that would challenge an unloaded hiker. The sun-drying process required constant attention and perfect timing. Rice had to be spread out on special drying platforms where it could get full sun exposure while being protected from sudden rain showers. Workers would turn the rice regularly to ensure even drying, testing moisture levels by biting individual grains to check for the right texture and sound. But here's what made the Ifugao system truly remarkable: the annual maintenance cycle that kept everything working perfectly year after year. As soon as the harvest was complete and the rice safely stored, work began immediately on preparing for the next growing season. This wasn't optional maintenance. It was essential preventive care that meant the difference between a functioning system and a mountainside full of useless stone piles. Wall maintenance was like performing surgery on the mountain itself. Every stone had to be checked for stability, with loose rocks carefully removed and reset. Workers became experts at reading the subtle signs that indicated which walls might fail during the next rainy season. A slight crack in the mortar, a stone that had shifted just a few millimeters, or a change in the sound the wall made when tapped. All of these were diagnostic clues that helped prevent catastrophic failures. The canal desilting process was equally critical and incredibly labor-intensive. Over the course of a growing season, flowing water would deposit sediment in the canals, gradually reducing their capacity to carry water efficiently. Workers would drain sections of the canal system and literally shovel out accumulated mud and debris by hand. The removed sediment wasn't wasted. It was carefully transported to the terraces where it served as nutrient-rich soil amendment. Resealing the paddies was perhaps the most technically demanding part of the maintenance cycle. The clay seals that kept water from draining away too quickly would gradually break down over time, developing tiny cracks and weak spots that could turn into major leaks. Workers had to identify these problem areas and repair them using the same puddling techniques used in original construction. The precision required for this maintenance work was absolutely incredible. A seal that was too thick would reduce the growing area of the terrace. Too thin, and it wouldn't hold water properly. The clay had to be mixed to exactly the right consistency, applied at precisely the right thickness, and smoothed to a perfect finish that would last through another entire growing season. What's most amazing about this whole system is the mathematical precision built into every aspect of the operation. The typical wall height of 1 to 2 meters wasn't arbitrary. It was calculated to provide maximum growing area while minimizing construction materials and labor. The canal fall of just a few handspans per 100 meters was the perfect grade to maintain steady water flow without causing erosion. The household work gangs that rotated between terrace clusters operated on schedules more precise than modern factory shifts. Each family group knew exactly when their labor would be needed for specific tasks, and the entire community's agricultural calendar was coordinated to ensure that critical work got done at exactly the right time. Miss your scheduled work period, and it could affect the productivity of dozens of other families. The turn-taking rules for water allocation were like having a complex legal system based entirely on fairness and community cooperation. Every family knew exactly when they would have access to irrigation water, how much they were entitled to use, and what their responsibilities were for maintaining the shared infrastructure. Disputes were rare because the rules had been refined over centuries to ensure that everyone got their fair share. This annual maintenance loop was what kept soil on the slope and water moving without pumps for generation after generation. It was a perfect example of sustainable agriculture that worked in harmony with natural systems rather than fighting against them. The Ifugao people had created something that modern engineers are still trying to figure out, a completely renewable system that actually improved the landscape rather than depleting it. The numbers behind this operation would make any modern agricultural economist do a double take. We're talking about a system where a single household might be responsible for managing 15 different terraces, scattered across 3 different elevation zones, each requiring different planting schedules, water management techniques, and maintenance cycles. The coordination required was like running a vertical farm that stretched from sea level to cloud level, except every employee was also the owner, engineer, and quality control specialist. But here's where it gets really mind-bending. These farmers didn't just manage their own terraces. The entire system only worked because hundreds of families coordinated their activities with the precision of a Swiss watch. When the upstream families opened their water gates, everyone downstream had to be ready. When it was time to drain the terraces for harvest, the timing had to be perfect across the entire mountainside, or rice would rot in some fields while others dried out too quickly. The water sharing agreements they developed were more complex than most modern business contracts. Every family knew exactly how much water they were entitled to during different seasons. But they also understood that their allocation could change based on rainfall, spring flow rates, and the needs of their neighbours. It was like having a stock market for water rights, except instead of making money, you were making sure everyone had enough to eat. What made this system absolutely revolutionary was how they dealt with the biggest challenge of mountain farming, keeping the soil from washing away. Most mountain agriculture fails because gravity eventually wins, pulling all the good dirt down to the bottom of the valley where it's useless for growing crops. The Ifugao people basically told gravity to sit down and shut up by creating a system where soil couldn't escape. The engineering behind this soil retention was pure genius. Every terrace was designed like a giant step, with the back edge slightly higher than the front edge. This created what engineers now call a sediment trap. Flowing water would slow down as it hit each terrace, depositing any soil it was carrying instead of washing it away. Over time, this actually made the terraces more fertile rather than less, because each one was constantly collecting nutrient-rich sediment from the areas above it. But they didn't just trap soil, they actively moved it where it was needed most. During the annual maintenance cycle, workers would carefully redistribute accumulated sediment from areas where it had built up to terraces that needed more growing medium. It was like having a soil delivery service that operated entirely by human power, with workers carrying baskets of premium dirt up and down mountain paths that would challenge professional hikers. The seasonal rhythm of this system was absolutely fascinating to watch. During the dry season, when water flow was limited, the terraces would be drained, and workers would focus on construction and repair projects. The wet season brought intensive planting and growing activities, with water management becoming the top priority. The transition between seasons required split-second timing and community-wide coordination that would impress modern logistics experts. One of the most remarkable aspects of the Ifugao system was how they handled crop rotation and soil fertility management. Unlike modern farms that rely on chemical fertilizers, these mountain farmers developed techniques for maintaining soil nutrients using nothing but organic materials and clever crop scheduling. They understood which plants would add nitrogen to the soil, which ones would help control pests, and how to time different crops to maximize both yield and soil health. The composting systems they developed were like having a recycling program for organic waste, except this recycling program could feed an entire community. Every scrap of plant material, every bit of animal waste, and even human waste was carefully processed and converted into fertilizer that would keep the terraces productive year after year. Nothing was wasted because waste was just another word for unused resources. But perhaps the most impressive thing about this whole operation was the knowledge transfer system that kept it running across generations. This wasn't the kind of information you could write down in a manual. It was hands-on expertise that had to be learned through years of practice and observation. Young people would spend their entire childhood learning to read water flow patterns, soil conditions, and weather signs with the accuracy of human instruments. The apprenticeship system was incredibly sophisticated. Children would start with simple tasks like carrying water or weeding, gradually working their way up to more complex responsibilities like adjusting water gates or reading terrace conditions. By the time they were adults, they possessed knowledge that would take modern agricultural engineers years of schooling to acquire, except their education was practical, immediate, and perfectly adapted to their specific environment. So there you have it, the most incredible agricultural achievement you've probably never heard of. The Ifugao people didn't just build some rice fields on a mountain, they basically rewrote the laws of physics and turned gravity into their personal farming assistant. These weren't just farmers, they were hydraulic engineers, master builders, soil scientists, and weather predictors all rolled into one, working with nothing but their hands and centuries of accumulated wisdom. Think about this the next time you complain about your commute to work. These people built a farming system so advanced that modern engineers are still trying to figure out how they did it. They created a sustainable agricultural miracle that fed entire communities for over 400 years, without depleting the soil, without chemical fertilizers, and without a single machine more complex than a wooden water gate. The numbers we've talked about today tell the real story. 1 to 2 meter walls that have stood for centuries, water canals that maintain perfect flow rates using nothing but gravity and human ingenuity, household work gangs coordinating activities across entire mountainsides with precision that would make modern project managers jealous, turn-taking systems for water allocation that prevented conflicts and ensured fairness, and an annual maintenance cycle that kept the whole system running like clockwork, generation after generation. But here's what really blows my mind. This wasn't just about growing rice. The Ifugao people created a completely sustainable relationship with their environment that actually made the landscape more productive over time. They turned erosion from an enemy into an ally, transformed steep slopes into fertile farmland, and built water management systems that could handle both droughts and floods without missing a beat. Today, when we're struggling with climate change, soil depletion, and water shortages, maybe we should be paying more attention to what these mountain farmers figured out 4 centuries ago. They proved that with enough ingenuity, cooperation, and sheer determination, humans can work with nature instead of against it to create something truly extraordinary. So the next time someone tells you something is impossible, remember the Ifugao rice terraces. Remember that somewhere in the Philippines, water is still flowing uphill through a system built entirely by hand, feeding communities just like it has for hundreds of years. Sometimes, the most advanced technology is the kind that doesn't need electricity, doesn't need computers, and doesn't need anything except human intelligence and the willingness to work together toward a common goal. That's the real lesson of the rice terraces. When people combine knowledge, cooperation, and determination, they can literally move mountains. Or in this case, turn them into the most beautiful and productive farms the world has ever seen.